Hello friends, welcome to another episode of CPP tutorial video. Today we will study about std mutex. std mutex is introduced as part of C++11. That is, to use std mutex, you must be using compilers which support C++11 standard. Hope you all watched the std thread tutorial video. If not, we strongly recommend to first watch std thread tutorial and then watch this video. std mutex is used for thread synchronization. So it is important to know about thread concept before learning about std mutex. The main topics covered in this video are introduction to std mutex, code usage of std mutex, and some examples of std mutex. Let's start with introduction to std mutex. Mutex concept is designed for inter-thread synchronization. As it is said earlier, a program may contain many execution threads for performing different functionality in parallel to each other. In most cases, multiple threads share a common data. Let us consider a real-world scenario. Imagine that a store contains two billing counters. Also, there is only one card swiping machine available for bill payment. Here, both billing counter performs billing in parallel for two customers at a time. But at the time of payment, both counters share the same swiping machine. Here, the thread is represented by billing counter, and the shared resource is card swiping machine. The functionality is bill payment. Now let's assume that customer at counter 1 has to pay $100 and customer at counter 2 has to pay $2,500. Let's check what happens if there is no synchronization at the time of payments. Here, as shown in the example, first the card of customer from counter 1 is swiped. Unfortunately, since there is no synchronization between counter 1 and counter 2 swiping card usage, the store employee of counter 2 entered the amount $2,500 before the store employee of counter 1 entered the amount. Unaware of this, customer 1 entered his PIN and the transaction is completed for $2,500 instead of actual $100 which he has to pay. This is a very big issue. Because of non-synchronized common data share between threads, this issue is occurred. Now let's revisit the scenario with synchronization applied. Here, as shown in the video, until the operation is completed, the swiping machine is owned by counter 1 employee. After completely performing the bill payment, the counter 1 employee gives the swiping machine to the counter 2 employee. That is, when the machine is being used in counter 1, the counter 2 payment was on waiting or on hold. Thus, there is no issue in payments. Coming back to our topic, according to C++ mutex concept, a class can be considered as mutex class if and only if it satisfies all of the following functionalities. 1. Lockable. A mutex class must have functionality to lock and unlock. This is the basic functionality every mutex class has to provide. 2. Default constructible. A mutex instance must be created using its default constructor, that is, without passing any additional parameter or without using any other functions. 3. Destructible. A mutex class which is constructed by default constructor must be able to invoke its destructor when the scope ends. 4. Not copyable and not movable. That is, this indicates that the ownership of mutex should not be transferable in any means. Currently, as shown here, there are many mutex classes available that satisfy the mandatory functionalities. The mutex currently available in standard template library are std mutex, std recursive mutex, std timed mutex, std recursive timed mutex, and std shared mutex. In this tutorial video, we are focusing only on std mutex. Rest all are of only slight variation of std mutex. std mutex is a class which is available in STL library from C++ 11 onwards. It is primarily used as synchronization primitive for inter-thread data synchronization. In almost all cases, std thread objects are created as stack objects, thus ensuring automatic destruction when the scope goes out. std mutex provides exclusive access to the critical code section, but std mutex is non-recursive type. std mutex provides non-recursive ownership, means it is mandatory that once the mutex is locked, it should be unlocked before it is locked again. That is, as shown here, if lock is attempted to repeat without unlocking, it will result in exception. For such usage, std recursive mutex has to be used. The correct usage of std mutex is to call corresponding unlock for every lock as shown here. Now let's check how one can use std mutex in the C++ program. The first step is to include the header file mutex. This header file contains the implementation of mutex class. Step 2 is to create an object of std mutex. It is upon the program's logic to decide in what scope the object has to be created. Here, in the example, mutex object is created in global scope. In step 3, the programmer has to identify the critical code section for synchronization. Once the critical code section is identified, use the mutex API lock just before the start of critical code section. Thus, the ownership of mutex is acquired by this thread. All other parallel threads trying to acquire lock shall wait for the owning thread to release this lock. The last step is to release the mutex ownership. Once the critical code section is executed, call the unlock API. This causes the thread to release its ownership. After that, any other thread can acquire the ownership. We have learned the importance of APIs and its usage. Now let us see one program using std mutex for thread synchronization. In this example, we are going to write a program that print two different characters from two different threads. That is, for example, thread 1 print star character and thread 2 prints ampersand character. The primary objective here is not to print this character as mixed. For this, we need to use std mutex and do thread synchronization. Here the print function shall print the character which is to be printed. This is the critical code section in our example. This print function is called from two threads, that is thread 1 and thread 2, with different parameters. That is, thread 1 have parameters as star character and thread 2 have ampersand character. Both these thread will print these characters 20 times. After thread is created, we have to join both the thread in the main thread. That is, this is to ensure that the main thread is returned only after both thread 1 and thread 2 has completed its operation. Now let's compile and run the application and check how the output is. As it is shown here, the character star and ampersand are printed as mixed. This is not our expected output. Now let's modify the function print function and apply synchronization using mutex. For that, we have to create a mutex object. First, we add std mutex lock before the output printing section. This output printing section is our critical code section. Also, let us unlock after output printing is over, which is our end of section, critical section. Let's compile and run the application and check how the output is. As you saw, the character star and ampersand are printed in sequential order. This is without getting mixed up. The characters are printed properly. Hope you all understood how std mutex enforced synchronization here. That is, the two threads start executing this thread function. Only one of the thread will get the ownership of this mutex, and the second thread will wait for the ownership in the mutex lock function. Once the first thread which got the ownership of mutex has completed its functionality, that is here has completed the printing of the characters for n count times, it will release the ownership using mutex unlock. Once the thread releases the ownership, the other thread which was waiting in mutex lock shall get the ownership of mutex and it shall start the execution. This is how using std mutex synchronization is applied and the desired output is obtained here. Now let's see the sequence diagram for the example we just used. Here, when the program started, two thread 1 and thread 2 are started sequentially. The main thread then start waiting for the thread 1 and after that it waits for thread 2. Only after both thread 1 and thread 2 ends, the main thread is exited. In thread 1, it acquires the mutex object using lock API. Meanwhile, the thread 2 also called mutex lock, but due to timing, thread 1 acquired the mutex ownership. Hence, thread 2 waits in the lock API for thread 1 to release its lock. The thread 1 prints the character 20 times and then release the lock by calling the unlock API of mutex. After that, the thread 1 is exited. That is, thread 1 ends. When thread 1 releases the mutex, thread 2 receives the ownership of mutex and it shall start printing its character 20 times. Once printing is completed, thread 2 releases the lock and the thread ends. After both the threads ended, main thread shall exit and the program exit. One important point here is std mutex in standard library is entirely different from Win32 mutex in Windows. The Win32 mutex in Windows are kernel object, whereas std mutex is not a kernel object. The std mutex is accessible only within one process, whereas Win32 mutex is a kernel object and hence it is accessible across different processes, especially if the mutex is named mutex. In Windows, std mutex is equivalent to Win32 critical section. In this tutorial video, we have covered basics of mutex, its usage, and seen some example programs. Please let us know your doubts, suggestions, and comments in the comment section below. If you have not yet subscribed to this channel, please do subscribe and press the bell icon for future video notifications. Please do like and share with your colleagues. Thank you for watching the video. Have a good day.